So we're looking at lesson 64 today. Angles interior to circles. So we're going to look at subtend, angles interior to circles. So a segment or arc is said to subtend an angle if the endpoints of the segment or arc lie on the sides of the angle. So looking at angle EDF, what angle subtends it? I mean, what segment or arc subtends this angle? EF, either arc EF or segment EF. Why do they subtend it? That's like where it makes it stop, right? The angle stops here. There are the two endpoints. That's where it stops. So what would subtend FED? FD? Okay. What would subtend GFD? ED. Okay. Yeah, I guess that'd work. Yeah, it is kind of like the side that's opposite it. But we're about to use the term subtend in something, so anyway. That's why I just wanted you to know what it meant before we got to this theorem, 64.1. So it says the measure of an angle formed by a tangent and a chord is equal to half the measure of the arc that it subtends. Or that subtends it. So let's look at angle ABC. Do you see angle ABC? Okay, what arc is across from it? If we have this angle here, this arc is across from it. And this angle is equal to half of the arc. The angle equals half of the arc. You'll see how that works? Yes. You learned it last year. But now we're getting to the theorem about it. Okay. Technically, I don't think so. Yeah. Like this angle would be half of that. Yeah. Okay? So this one says CBD. Do you see angle CBD? Okay, and it's going to be half of the arc that's opposite it. Well, what arc is opposite it? BC. So it's half of arc BC. Y'all see how that works? And we did this last year in Algebra 2, so you may remember it from that. But now we actually got to the theorem about it. So let's look at an example. We want to find the measure of PQR if they tell us that PQ is a tangent and arc QR is 100 degrees. Is the angle 50? Why? Because it's half of that 100. Also, since it is tangent, what do we know about this angle here? So if this angle right here is 50, what does that make that? Does that make sense? And then I could draw a radius here. Well, no, I won't do that. Okay. Looking at the next one. Angle DEF. We want to find it if EF is tangent. DEF? Which one? Okay, what about arc DGE? Why is this 250? Because what does the circle add up to be? 360. So if that part is 250, what is our angle DEF? 125. Y'all see how that works? Okay. Looking at another theorem. Theorem 64-2. And it's our last theorem for today. No, there are no corollaries, just some more examples. The measure of an angle formed by two chords intersecting inside of a circle is equal to half of the sum of the intersected arcs. So let's look at our little picture. Angle 1 is equal to half of its intercepted arcs. Well, what are the intercepted arcs dealing with angle 1? Which one? No, not AB. What angle, what arc is kind of like opposite 1? BC and AD. Angle 1 equals half of AD plus BC. It's like the average of the two. I'm going to draw another little picture real quick. This is the center. If this arc is 50, what is this angle? What is it? This angle? 50. Because it's in the center. The central angles are the same as the arc. And what is this angle over here? So what does that make this arc? But what happened up here is we took them and we pushed it over here. And so what's going to happen to the lines? They're not going to stay exactly like this. They're going to one's going to, yeah, they're going to get bigger or smaller. But they're still going to average out to be the same. Okay, so let's look at angle 2. It's going to be half of which two arcs? AB and CD. You'll see how that works? Any questions on this part? Okay, so let's look at an example. So find an expression. We're not going to have an actual number answer for angle 1, but angle 1 would equal what? Okay, arc WC. Okay, plus arc XY. 1/2 of that. Because that's what the theorem said. Yep, that's it. 2 and 3 are irrelevant. Yeah, I know. If you really wanted to use the 2 and 3, this is 2 times angle 2, right? Because it's double the intercepted arc. And then this one will be 2 times angle 3, right? So if this was 50, this would be 100. So like 2 times it. I know the 2 angle 3 kind of looks funny. Yeah. But you would say 1/2 of 2 angle 3 plus 1/2 of 2, oh, I already put this, plus 2 angle 2. But what is 1/2 of 2 angle 3? Yeah. And what is 1/2 of 2 times angle 2? So that's true too. You could also use the remote interior triangle theorem. This is, remote interior. This is our exterior angle, and it equals the sum of the 2 remote interior angles, 2 and 3. Okay? And circumscribe. Because we don't know that one's in the center. You can use it whether it's in the middle or not. Because if the 2 arcs are the same, well, if you made 100 on both your tests, what's your average? 100. If you made 50 on both your tests, what's your average? The 50. So if the arcs are the same, then the center would be the same. So the average would be fine. Yeah, and they're vertical angles. Okay? Let's look at another example. Use the information in the figure to find the measure of arc in M. What could we do? Plus what? Why? Because that's your formula? Okay, so what would I do? I don't want to do that. Because then I'm going to have half of it in M. What could I do instead? double both sides, and the 1/2 and the 2 would cancel out, but it would still double on the right side, or left side. Multiply both sides by 2, and so that 2 and that 1/2 go away. That way, at the end, you don't forget to have to double your NM, because you'd have half arc NM. No. And then you can check it. I'll plug a 30 in here. 30 plus 92 divided by 2 should give you 61. Do y'all see how that works? Okay. Let's look at another example. The diagram shows a plan for a turntable for a model train. Do y'all know what a turntable is for a train? Like if you have all your tracks and you can twist it, so instead of making your train go this way, if you had another track coming over here and here, you could turn it so that your train would go here. Like it just turns the direction of your train. I don't know if they have them in real life or not. What would AOD have to equal? Molly says 55. Shares with Molly. Kayla's with you. Do I need to go over why it is 55? Okay. Let's look at some practice problems. Just practicing using those theorems. Find the measure of angle S. What is it? 102? Okay. It's half of this part. So half of 204 is 102. Okay, what about the second one? See if you can figure out what MNO would have to equal. How do you know? Double it. Okay. Looking at another 2. See if you can figure out the measure of angle X. What do you think it is? 1. Add up divided by 2. Okay. What about this last one? A long drawn out question to say, what is the measure of arc M? How? It would have taken you longer to read the question than to just get to the end. Do what? Oh no, I think they just made it up. Alright, so let's look at a challenge question. You don't have to actually write a paragraph of proof. I just want someone to be able to explain it. Given an angle with its vertex on a circle, formed by secant ray and tangent ray. The measure of the angle is half the measure of the intercepted arc. Theorem 64.1. Half the measure of the arc. And it gives you some letters just to help you be able to, like, call it. Instead of having to say A, D, B, you say angle Z. Wait, what? Arc AB. You gotta keep going. What? Okay. Yeah, but that's what the theorem says. They want you to show a way to get there. Show how to... Okay. I think it's it's a theorem that says that a tangent line is perpendicular. Okay. So that means that x plus y equals 90. So this is the right angle here. So x plus y has to equal 90. Okay. Do we know that Z is a right angle? We really don't. So it's just isosceles. Okay. So Z plus 2y equals 180. Y equals what? Yeah, we're trying to get there. No, because those lines aren't parallel. Right? 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 Is that the same thing? Up here? Okay, now what? Isn't that what our theorem says? Does our theorem say that double x you get z? So that's another way to prove it, basically. Okay, when is your homework due? Why not Monday?